Hi, it's me, Dr. Prasad Puthiyillam. Continuing my classes on inorganic laboratory. This is class on dissolved oxygen determination by Winkler's method. Dissolved oxygen, it is nothing but the oxygen which is in the dissolved state present in water. So usually 7 milligram per liter at 1 atmosphere pressure, it is the desired amount of oxygen to be present in water. This is required for the aquatic life as well as for the oxidation of impurities present in water. Usually organic impurities in water as well as large amount of algae growth reduces the dissolved oxygen content. Estimation of dissolved oxygen was first reported by Winkler in the year 1888. Therefore, this method is known as Winkler's method or Winkler's iodometric titration. So Winkler's iodometric titration, iodometry is based on the fact that the alkaline medium dissolved oxygen oxidizes Mn2 plus manganese 2 plus to Mn4 plus, which in acidic medium oxidizes iodine I minus to free iodine. The amount of iodine released can be titrated with a standard solution of sodium thiosulfate, commonly called as hypo solution, and is equivalent to the dissolved oxygen originally present. Therefore, the reactions, if you consider Mn2 plus in alkaline medium OH minus, takes the dissolved oxygen to become MnOH twice, which precipitates, which in acidic media, the I minus reacts with I minus, and the equivalent amount of iodine will be released, which is corresponding to the dissolved oxygen. The released iodine, or in terms the amount of oxygen present in water, can be estimated by titrating with the sodium thiosulfate of hypo solution. The main interference caused in estimation of DO or dissolved oxygen is presence of nitrite, that is mainly in sewage treatment water samples. It can be avoided by adding sodium azide, which destroys the nitrate present in the sample on acidification. The reagent preparations, 50% manganese 2 solution is prepared by approximately weighing 5 gram manganese 2 sulfate monohydrate in 10 ml water. Alkali iodide mixtures were prepared by weighing 10 gram sodium hydroxide and 5 gram of potassium iodide in 25 ml water. 200 ml of the water sample, it is taken in a 250 ml reagent bottle and it is closed properly so that the atmospheric oxygen should not mix with the water. Then 1 ml of 50% Mn2 plus solution is added. To that 2 ml of alkali iodide is added. That time we are getting a brown precipitate. During all this addition also, we should be very careful that the extra atmospheric oxygen should not mix with the water sample. So it is allowed, the precipitate, brown precipitate is allowed to precipitate, and after some 15 minutes, 5 ml of concentrated sulfuric acid is added, which dissolves the precipitate, the brown color precipitate obtained. That means it liberates iodine. The liberated iodine is titrated against sodium thiosulfate or hypo solution using starch as indicator. Usually the indicator is not added in the beginning stage of the titration, it is added near to the end point. When color becomes pale yellow color, that time starch is added and the titration is continued. We'll get the color change from blue to colorless. Before doing the experiment, actually we need to standardize the sodium thiosulfate or hypo solution. To that we need to prepare standard potassium dichromate. Approximately 0.31 gram of potassium dichromate crystals were dissolved with dilute sulfuric acid and made up to 250 ml standard flask, made up to the mark and shaken well for uniform concentration. The strength we can calculate as weight by equivalent weight of potassium dichromate multiplied by 4. Since we have prepared 250 ml only, strength normality is calculated in terms of liter. Equivalent weight of potassium dichromate is 49.03. In burette, hypo solution is taken, sodium thiosulfate is taken in burette, 10 ml potassium dichromate and 2 ml alkali iodide and 2 ml constant sulfuric acid were taken in conical flask. Starch is added near to the end point, or when the color become pale, the color changes from blue to colorless. Here the strength of the hypo solution can be calculated as normality in volume of potassium dichromate divided by volume of the hypo solution. So this what we did on estimation of dissolved oxygen, the titrator with sodium sulfate with the starch as indicator. The starch is added towards the end point or near when the color becomes pale yellow, because the starch can form iodine complex. Iodine will adsorb on the surface of starch, becomes a dark blue color complex. So if large amount of iodine concentration is there in conical path, that time if you add a starch, the iodine may not come out easily as the hypo solution is added, and we may get a wrong titer value. Therefore, iodine is when the iodine concentration is less, that time starch is added to the solution, so that we'll get the accurate endpoint. So that's about the estimation of the usage of starch. So the amount of dissolved oxygen, it is calculated as normality into volume of hypo solution divided by volume of water, that is in gram per liter. We need to express the dissolved oxygen in milligram per liter. The value is multiplied by 1000, that is milligram per liter. So that's about the dissolved oxygen experiment. Hope it is you understood the concept and the calculation part of that. And thank you very much and have a nice day.